Okay, guys, picking up where we left off yesterday in 4.1, finishing these notes up, we are ready for lesson or example. I guess it does have a number. The next example. The running lanes at the Emory Sears track at Bluffton College are 1 meter wide. The inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? So not a rainbow. This is a track around one turn. Okay? So technically, if you ask me, this would be around 2 turns, because it's an end, but we're just going with what the problem says here, okay? So I would say let's go ahead and put some information on this page or on this track so we know what it is. So the running lanes at this track are 1 meter wide. So what's that tell me here? That is 1 meter wide, and that is 1 meter wide, yes? Okay, that's a visual. You've got 2 tracks or 2 lanes, and each lane is 1 meter wide. The inside radius of lane 1 is 33 meters. Thoughts here? What do we mean radius? What's radius normally?
From the center of the circle to one side.
Okay, from the center of the circle to the edge of the circle, right?
Yeah.
Now, in this case, what you're looking at is your center of your circle is right here, because basically what they're showing us here is half a circle. Can you see that? They're showing us half a circle. The inside radius, so you know where the inside of the lane is, we're going from the center of the circle to, that would be the inside radius of lane 1. And this was, did I say 33? That is 33 meters. Now, for anyone that is a little challenged in what we were talking about with track, I guess I should go back and talk about, are we familiar with lane 1 versus lane 2?
Yes.
Lane 1 is going to be your innermost lane, and you number out from there, yes? So lane 1 is on the inside of the track. Usually there's, about 8 lanes? Okay. So, the inside radius of lane 1 is 33 meters. Inside radius of lane 2 is 34. So what are we saying here? From, yeah. So from there to there is 34 meters. What? You don't like that I drew it over there?
No, I messed it up on my own.
Okay. So, which doesn't make sense that it's 34, that's 1 meter more?
Yeah. Why did they give us that?
Just
They
go with
said
it.
inside 33 and there's
Okay, inside's 33. It would make sense that the next one is 34 because it is 1 meter wide. So 30, add the 1 onto 33. Okay, how much longer is lane 2 than lane 1 around one turn? So basically, if this is one of the races where you have to stay in your track from here over to here, right? Just around this turn. We're just going based on the picture, okay? From here to here, how much farther is the person lane 2 running than the person lane 1 running? Now, thoughts of what we're going to do here? I need a more specific answer. We're going to have to find the arc length
of both lanes.
of both lanes. Do you remember learning arc length yesterday?
Yes.
That's the formula right above. Right? So we have that arc length of, we're going to find arc length of lane 1. And we're going to have to find arc length of lane 2. Formula for arc length is S equals R theta. So we're going to do lane 1, we're going to do lane 2, we're going to find the arc length of both of those. Now, when we talk about how far they're running, we're just, and notice they gave us the distance to the inside, right? Technically, a good runner is going to hug the inside line, right? Because they're trying to run the shortest distance. So that's what we're going to find the length of there. So what do we have to know?
Radius.
Okay. We have to know radius. What's my radius for lane 1?
33.
That's 33, right? Because it's going from here up to here. And keep in mind, what we're going to be finding first is that right there, yes? That's what we're finding. Is where, I don't know if you can even see that dotted line I just put in there, but. So we know our radius. So we're going to know S equals radius of 33 times theta. Not 2 pi. What did you say?
We don't have it. We don't have the degree.
It's
But
one.
they're only traveling.
Okay, it is 180,
Yeah.
but 180 is not 2 pi.
3 pi over here.
No.
No.
Okay, you don't know enough about the unit circle to just kind of try and look at the unit circle. So first of all, okay, wait, time out.
Would it be one?
Why are we saying 180?
Because it's.
Because you're looking, there's your angle there, yes? And what is that angle? That angle is,
Approximately 180.
that's a straight line, that's 180 degrees, right? Now, for review, how do we change from degrees to radians? You multiply by pi over 180. And 180 times pi over 180 is pi. So while yes, this is 180 degrees, remember we talked yesterday that the formula S equals R theta only uses radians. It will not work with degrees. So we're going to use pi for our angle.
That's where I'm at.
Okay? So we're going to say the arc length of lane 1 is going to be 33 times pi. What is 33 times pi?
103.67.
Okay. I wrote down 33 pi. 103.67 is also correct, yes? Write down either or. Write down both. Because our answers in the end should be the same as long as you don't round too much. So keep a couple of decimal places, right?
Got 2, is that okay?
Minimum 2. If it doesn't work out, we'll know you should have kept 3. I guess it depends if you had to round at the end or not. So,
I rounded.
okay. Lane 2. What do we know about lane 2?
34.
My arc length, or my radius, is 34. What's my theta?
Pi.
Same angle, yes? The difference is now we're trying to find this distance, right? Try and find the inside of lane 2. And so it's still the same angle. We're just going out to 34. So 34 times pi.
106.8.
Okay, 106 something. I'll go with it. I'm going to write 34 pi. And we're both going to get to the same answer. Okay? Now, what are we actually trying to find?
How much farther?
Yeah.
Okay, how much longer is lane 2 than lane 1 around this turn? So what are we going to do?
Subtract.
Yeah, we're going to subtract them. We're going to take lane 2, which is the longer one, right? And subtract lane 1. So on mine, I'm going to do 34 pi minus 33 pi. What is 34 pi minus 33 pi?
1 pi.
1 pi. And what is 1 pi? I'm going to go with a basic 3.14 meters. Okay, now, if you went ahead and went decimals earlier, it worked out, didn't it?
I don't know.
You gave up on
I
it.
did both and it worked out.
Now, not that you would have realized this, I know this problem, but I never had to pick up the calculator. Yeah, because when I got to the end, it was 1 pi. Now, if it was something other than 1 pi, I might have had to pick up the calculator. Because do I want you to leave your answer as pi? No, you don't answer how much longer is lane 2 than lane 1 as pi. That's not what we say here, okay? You know, you would want an actual distance. Okay, so another application of your arc length formula, okay? We'll use that randomly throughout the chapter and whatnot, okay? More right now, but it will still pop up. Okay, let's see, I just thought, oh, I do have it up. Okay. This is the one that we're going to spend our most time on, and I should have written that comment out in the middle. But we're going to talk about angular speed. You know yesterday how I was trying to take you through conversions, where we do fractions, we're trying to get units to cancel. What you guys have done in chemistry is what it always gets compared with. You've learned in other math classes. Okay, that's what we're going to end up looking at right here. Angular speed, measured in revolutions per minute, or more commonly referred to as RPMs. If you have an RPM dial on your dashboard,
It goes really high.
it shouldn't go really high sometimes. Okay,
That's why there's.
but anyways, angular speed can be changed to linear speed, measured in units like miles per hour. Okay, by conversion factors like we use to change radians to degrees. So again, we're going to be talking about multiplying by fractions, getting units to cancel. Now, one thing I should have written in here beforehand so you guys could go ahead and be writing it. Kind of forgot. I'm going to put it right here. This is a little side note that we need to get in here. And that says a central angle of 1 radian. This is just a fact that we need to have. Intersects an arc the length of the radius. So a central angle of 1 radian intersects an arc the length of the radius. So the short of what, that was weird. The short of what I'm trying to say is that one of the pieces you're going to have to know when we do these conversions is that 1 radian, okay, so a unit of 1 radian, is always going to be equivalent to the radius of the circle. Okay, and that is something that's going to apply to all the problems as we go throughout this. Okay, so when you see them in homework and whatnot, this will apply here. Okay, now, hold that thought in the back of your head. The example we're going to do here. Albert's truck has wheels 36 inches in diameter. If the wheels are rotating at 630 RPM, rotations per minute, which, by the way, rotations per minute, revolutions per minute, same deal. Find the truck's speed in miles per hour.
So rotation is just like 1 whole.
Yeah, like, so when we talk about a revolution per minute, a revolution is going to be 1 rotation.
Oh, okay.
So whether I say, and you know, here's a perfect example, it's not consistent with the wording, but a revolution or a rotation. Okay? Same thing.
That's so interesting.
Okay? Equivalent or interchangeable words here. Okay, so our final goal is to find the truck's speed in miles per hour, right? Like, I'm going to probably end up erasing this later and rewriting it better, but here's my goal, right? That's where I'm trying to get to, is so many miles per hour. Now, with that in mind, where's our starting point? What do we know? What are we trying to convert? Yeah. My wheels are rotating 630 rotations per minute or revolutions per minute. So I'm going to start over here, and let's just say I'm going to use like most of this space across the way. I'm going to start over here, and I'm going to set it up as 630 revolutions per minute. Okay?
Oh, diameter. Oh my
Now,
god.
okay. Which, it also said the Albert's truck had wheels 36 inches in diameter. If we're
that
talking
like
36 inches in diameter, what else do you need to know? Okay, if the diameter is 36, the radius is going to be 18 inches. Are we going to have to use that eventually?
Yes.
Most definitely. Okay, so our goal is to take revolutions, turn it to miles, minutes, turn it to hours. This is where we're going to use our conversion factors. Okay? I was just going to say, give me the obvious one to get us started here. We're going from minutes to hours. Known fact, 60 minutes in 1 hour. So when I teach this, I say we can either do 60 minutes over an hour or 1 hour over 60 minutes.
What do you want minutes over hours? The minutes cancel.
Exactly. So we want minutes over hour, and there's 60 minutes in 1 hour. And I want minutes over hours because I want minutes to cancel. This is sounding familiar, right?
Can we have parentheses?
Sure.
Does that make a difference? Okay.
No. Parentheses, multiplication dots, not caring there. But my point is that minutes and minutes are going to cancel. I'm going to worry about all my numbers in the end. I'm not doing anything with numbers till I get to the end. And so right now, if we stopped right now, we would now have revolutions per hour. Okay, we're going to get there. Okay, now, we've got to get out of revolutions, yes? Okay, what is a revolution?
One rotation.
One rotation. One go around.
Sorry.
What do we know about that one revolution or that one go around? Or
Oh, that's
it's 360 degrees or it's 2 pi.
Spins
Oh,
once.
so 2 pi is like all the way around.
Yes.
Not.
Okay, and here's the deal. As we start to work with the unit circle, 3 o'clock is your home zero, begin and end.
Okay.
Okay, that's what you have to remember. Is unit circle begins and ends at 3 o'clock. I know, confusing, but we'll get there. So, and you'll notice it says 2 pi / 0 on the unit circle over there now. Okay, so we're trying to get out of revolutions. Eventually, we'll get 2 miles. Let's one step at a time. As I said, I'm going to use this space here well. So, 1 revolution, you could say is 360 degrees, and then you have to say 360 degrees is 2 pi radians. Or I was just going to go 1 revolution is 2 pi radians.
Oh, yeah.
Okay? Now, with that in mind, same question as earlier. 1 revolution over 2 pi radians or 2 pi radians over 1 revolution.
2 pi. You want revolution?
2 pi radians on top over 1 revolution on bottom. And we want revolutions on bottom because we are trying to get it to cancel. So, side note over here if you need it, 360 degrees is equal to 2 pi radians. If you'd rather make that a fraction in your problem, then go for it. Okay? Okay. So now if I stop now, I have radians per hour.
The tires not spin.
Okay. Well, okay.
Miles are not high.
Here's the deal. This is our jump at this point. This is where, okay, my red starred comment from up above. This is where we're going to jump and get to something that you guys can work with.
Yeah.
A central angle of 1 radian. What are we in right now? Radians. A central angle of 1 radian intersects an arc the length of the radius. So that says that 1 radian is always going to be equal to whatever the radius is. Don't think 2, just think 1.
2,
So 1 radian is going to be
18.
equal to the radius of 18 inches.
Yes, you just multiply the radius.
I'm not going to multiply anything by 2. I'm going to set up my fraction here. I'm just trying to convert out of radians at this point. So I can either say 1 radian
2 radians.
over 18 inches, or I can say 18 inches over 1 radian. Who cares if this is a 2 pi right now? I only care about I'm trying to get out of radians. Forget 2. Okay, so we want to get rid of radians. We want radians on top, right? Or on bottom, excuse me. And 1 radian is equivalent to, in this problem, 18 inches, because 18 inches was the radius. So my starred comment creates that fraction right there, creates that conversion unit. Okay. We're getting closer. We're at, what are we at right now? If I stopped the problem right now? Inches per hour. Well, at least you should know where to go from here.
How many inches are in a mile?
I don't care how many
No.
inches are in a mile.
Don't do inches, then go to feet per mile.
How many feet are
I can do,
5,200 feet.
that's one you need to learn to know.
Yeah, you need
But
to
now,
know.
hold on, inches. What do we know about inches?
They're
12 and a foot.
12 inches in a foot. And then one thing that you should learn to know, especially at this level, is you need to know feet and mile. Okay? So,
6 inches.
now,
3 feet.
inches is on top. So if I want inches to cancel, we're going to say 1 foot is 12 inches. I put inches on bottom, so inches will cancel. Now, if I stop now, I'm at feet per hour. I don't want feet per hour. Feet per, how many feet in a mile? So 1 mile is 5,280 feet. Learn it, know it. Okay, so now my feet cancel. And where are we at? Miles per hour. What was my goal? Miles per hour. Now, you still have one more challenge to get the right answer.
Everyone got the right answer.
Well,
That is your challenge. Everybody, grab your calculator out and try it.
I don't know where to start.
Exactly why we're all going to try it. I can show you a couple of different ways you could do this. But, there's not just one right way. There's also not just one wrong way.
Everything else is
I got
it's
really
1 mile an hour.
So did I.
I don't think that's right.
Mario, what'd you get?
What'd you get?
I got 67.
He's going speedy fast.
How did you? What did you
I did
start?
not.
I multiplied everything,
Okay,
And then you divided
and
by
then I divided.
so here's an option.
Oh,
shoot.
Okay,
You don't.
everything on top.
I know, I messed up.
And there's a couple of different, as I said, there's right ways and wrong ways to do this. One thing, if you want, you can do a fraction bar. You don't have to do a fraction bar. But I could put on top 630 times 60 times 2 pi, please use pi and not 3.14, times 18, 1 and 1, I'm not going to bother putting in. And then my denominator I could do 12 times 5280. That's one way to do it. Okay? Now, and this is where I encourage you. If you have a way that you want to try, this is where you try it now, yes?
Yep.
Because then you'll know did your way work or not. Now, another option, if you're not a fraction bar person, you will also see me do 630 times 60 times 2 pi
I'm forgetting the
times 18 into parentheses, divide, begin parentheses. That is important to put parentheses in the denominator. 12 times 5280. That would get me there. If I just go left to right, I could say 630 times 60 times 2 times pi times 18, divide by 12, divide by 5280. Now, I will warn you to be careful. If your 2 pi is in the denominator, you have to be very careful because it will see 2 and pi as 2 separate things. So you have to be careful of how you handle that. I don't know. Did everyone find some way they liked to do this? Okay. So, final answer. I wrote 67.47 miles per hour. 67.5 is equivalent, obviously.
Now, on most roads, that could be considered speeding.
Yeah.
Wow.
Okay.
I did about 60 miles.
Put work into figuring these out, guys.
That was
Do me a favor and don't just sit back and say, oof, I can't do those. Yes, you can. The one thing you're going to have to learn to remember, I would say those two are the pieces that are a little new to you, right? The rest of this is probably old news. So. Okay, one more. We have a conversion unit here, or actually 2 conversion units, for nautical miles and statute miles. A nautical mile is length of 1 minute of arc along the Earth's equator. A statute mile is what we talk about. How many miles do you live from school? That's, okay, so statute mile, as it says, the familiar land mile. So the idea of nautical miles and the conversions between just regular miles. So the conversions between nautical and statute miles. A statute mile, you can go one of 2 ways. You can say 1 statute mile is approximately 87/100ths of a nautical mile, or 1 nautical mile is approximately 1 1500ths statute miles. Okay, so, and again, notice the definition. A nautical mile is the length of 1 minute of arc along the Earth's equator. Okay, now, interesting enough, this problem is not talking about sailing anywhere, but we're going to talk about flying. Megan McCarty, a pilot for Western Airlines, frequently pilots flights from Boston to San Francisco, a distance of 2,698 statute miles. Her flight time calculations are based on nautical miles. How many nautical miles is it from Boston to San Francisco? And this has all to do with a plane. If you ever look at flight lines, they don't take off from Indy and fly directly a straight line to Boston or San Francisco, do they? Okay, there's a curve involved, and don't ask me the details behind that because I certainly don't remember it, but there's reasons, okay? Now, thoughts on what you want to do on this problem?
How do you find the curve if you don't know them?
Oh, you're thinking way too difficult here.
It's just like a single.
There's that many statute miles.
Then why would
You
then
take
why
that
would they pick the
divided by the
complicated
nautical mile.
ones? Right.
They give me a statute miles.
Yeah.
We're converting to nautical miles.
1.5. No, you see. 2698 divided by 1.5. 1.15.
Okay. One option is 2.6 or 2,698 divided by 1.15. What's the other option?
Multiply it by 0.87.
2,698 times 0.87. Officially, does it technically matter?
What's the abbreviation for nautical miles? Is there one?
I just put it in.
I've been using NAUT. I don't know what it is, honestly. So, now, if you're looking for a setup, my setup was 2,698 statute miles. If I think in terms of fractions, I'm going to put it over 1. And then since I'm trying to get rid of statuette miles, I'm going to put statuette on top, right? I use the conversion that 1 statuette mile is approximately 0.87 nautical miles. Okay? And so then I was just multiplying. Either way, we should have a similar answer. I'm not sure if it comes out identical. I got 2,347 and 2600ths.
Yep, when you divide, I got
What'd you get?
2,346 and 0.08.
Okay. I knew it was close, but not quite the same. Okay.
It can't be exact because it doesn't say they equal each other. It's the approximately equal sign.
Okay, guys, your homework, which will be due Monday, is on page 318. 2 through 42 evens. 45, 50, and 51. And you have a little bit of work time. I would encourage you to use it.